We shall now explore two teaching and learning activities which use the array structure to visualise equal-sized groups, then calculate the total number in the array. The first parallel task is for years 1 to 4 and designed to construct multiplication and division facts through increasing counting skills. We will sequentially move through the task to see how I've differentiated it so that all students in the class can access and engage with the activity regardless of where they are at in their development, from using repeated addition to being able to represent and explain the commutative property in a variety of ways. The second task then progresses to using an area model where the commutative property, or turnaround facts, are so beautifully made visible. Let us begin with a student-centred parallel task where children work in pairs but make their own individual recordings on a dot array student recording sheet insert. I like to provide children with explicit instructions through the strategy of make it, say it, build it, draw it, and then write it. Player 1, the student sitting on the left of the pair, for example, goes first. They roll the 2 dice into the bowl, which is placed at the top of the table between the pair, to make or randomly generate their 2 numbers. Then they say how they will use their numbers. For example, either 3 groups of 5 or 5 groups of 3. Next, they build it by modelling with connecting cubes. However, if your students already have an understanding of the difference between groups of and the number within each group, you may want to omit this step. Next, they draw it by placing loops around the dots. Finally, they calculate the total number of dots they have looped and write it symbolically. To do this, I say to children, sometimes I have trouble remembering what number I'm up to when I'm counting, so I like to write down the number of where I'm up to at the end of each row. In this way, we are maximising the learning outcomes by sequentially connecting concepts as follows. Firstly, stress counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then there are the symbolic written recordings of 5, 10, 15, which represent skip counting, as well as connecting their thinking to the multiples of 5. While player 1 is making their written recordings, player 2, the person sitting on the right, has their turn and goes through the same sequence but with their own numbers. The task then continues as a turn-taking activity, and the winner is the first player to fill their sheet. Alternatively, you may want to specify a time frame, such as 2 minutes, half 8, and the winner is the player who has looped or claimed the most amount of dots. This provides a wonderful opportunity to ask children questions such as, who won? How did you count the total number of dots you circled on your page? How much did you win or lose by? Let us now progress to using an area model, where the commutative property or turnaround facts are so beautifully made visible. Firstly, it's important to organise the student's desk space. I always have the children remove everything from their tables before handing out materials. I then start by handing out the student recording sheet inserts, 1 per page, followed by markers and erasers, 1 per student. We then set up our game boards with a sequence of explicit instructions which go a little like this. Instruction 1, double a half. Place your page in landscape orientation on your desk between you and your partner. Instruction 2, double a quarter, or a half of 4. Divide your page, or paddock, or playing field, in half by shading in 1 vertical column. At this point, I actually don't tell the children it's a 25 by 18 array. I just watch them count all the squares, as very few of them read the footer on the page. Instruction 3. Half 12 or a quarter of 12. You now have your own half of the page or paddock. Please write your name at the top of the board on your side. While students are dividing their page in half and writing their names, this buys us some time, about 60 to 90 seconds, to walk around the room and place the bowls and dice on their tables. I now like to manage the learning environment and address student engagement through the use of the strategy make it, say it, draw it, write it. Similar to the first parallel task, player 1 makes their two numbers by rolling two 0 to 9 dice into the bowl. They then say what they will do with their numbers using mathematical language, such as multiplied by or the product of, rather than everyday language, such as lots of or times. Next, they represent the multiplication fact by drawing a rectangular array that corresponds to the fact they have verbally identified. That is, the numbers rolled are the dimensions of the rectangle. Finally, they write the number fact inside the rectangle. While player 1 is making their written recordings, player 2 has their turn, moving through the same sequence, using the same mathematical language, but using their own randomly generated numbers. The task then continues as a turn-taking activity, and we can now start to clearly see that the multiplication fact gives the total number of square units in the rectangle and therefore determines its area. The winner is the player who covers, or has claimed, the largest area in a specified time frame, such as 5 minutes, square root of 25. This provides an opportunity again for us to ask children, who won? How did you work out the area covered? And how much did you win or lose by? After completing the task, this idea can then be extended to multiplying larger numbers using partial products. This then beautifully leads to the distributive property in the wonderful world of Year 7 algebra. This now completes our journey together, and now it's up to you to decide which aspects you'll trial back in your classroom on your adventure. So, safe travels, keep your concrete materials in check, and I look forward to hearing about your journey in the forum. Have fun!